experiment, we examined the relationship between the mass of a demolition ball and the object that it's knocking over. To recreate this on a very small scale, we used a textbook as our building or object to be knocked over, and 3 objects of different masses as our demolition ball. Our smallest object was a sock, our next object was a tennis ball, and our heaviest object was a toy lizard. Each object was tied to a string whose axis is placed directly above the textbook. When released, this object on the string becomes a pendulum, and so we can examine the equations associated with pendulums to examine how much force and momentum our object will exert on the textbook. Once released, our object swings and hits the top of our textbook, which it must hit somewhere in the top third so that it is above the book's center of gravity. And the object, at this point, when released, all of its energy is potential at the top, and you can find an object's potential energy using the equation. Potential energy equals mass times gravity times height. When it swings, all of its energy is converted to kinetic energy. Kinetic energy can be found by multiplying 1/2 times the mass times the velocity squared. And at this point, because the object is moving, it has momentum. And momentum is represented with a P by multiplying mass times velocity. And the textbook, because it is stationary, has no momentum. So when the object swings, all of its momentum is transferred into the textbook. If the object's momentum is great enough, the textbook will fall over. As the falling objects generally have very similar speeds as they're falling on a momentum, so the velocity, we can say, is constant. The mass, however, is changing, so the momentum increases when the mass increases. In our smallest object, our sock, when released, the momentum was so slight that it had a negligible effect on the textbook, and the textbook remained vertical. Our tennis ball had a greater mass and therefore greater momentum. So when it hit the textbook, it caused the textbook to fall over. Our lizard had the greatest mass, and so when it was released, it hit the textbook with a large force, causing it to fall over. Next, I'll talk about the importance of where the object hits on the textbook. This is our textbook. We can imagine it's like a door. When it falls, it will either fall to the right or to the left. And the center of the textbook will always be close to this point. Therefore, we can identify this point as the axis of rotation. So, to get in a rotating object, to get the most result from the least force, it's necessary to apply the force as far from the axis of rotation as possible. So exerting a force on the textbook here a force must be much larger at this point to cause the textbook to fall over than the force must be at this point. So had our string been longer and our object had hit at the bottom of the textbook, our objects would need to have been much larger so that their momentum and force would have been greater. This principle is called torque, and we want the maximum amount of torque for our object on the book to get it to fall over with the least amount of effort.